Now we're going to look at the symmetry of time dilation. If you remember, when you see a moving person, a moving frame of reference, their clock will go slowly, it will go slower than yours. Moving clocks go slow. So I observe the other clock as going slower than mine because it's moving. But they see my clock as moving, so they see my clock as going slower than theirs. So who is right? Is their clock going slower than mine, or is my clock going slower than theirs? Well, we're both right, because from our frames of reference, I will see that his clock is going slower, and they will see that my clock is going slower. We are both correct from within our frames of reference. Describe how the concept of time dilation leads to the twin paradox. So we have this symmetrical situation, that I see them as going slower, they see me as going slower. I observe my twin travelling at almost the speed of light, and he sees me travelling at almost the speed of light. Who is correct? Well, we're both correct, because from our own frame of reference we see the other person as travelling almost at the speed of light. There's no way of finding who is actually moving and who is not. Now, I observe my twin. I notice his clock moves slower than mine, so that means he must age less than me. My twin observes me. He notices my clock is moving slower than his, so according to him, I age less than him. Who is correct? Well, we are both correct from our frames of reference. Now, what if we stop and we meet and we speak to each other? My twin goes off into space at 90% of the speed of light and comes back and we meet. Who has aged? Now, when we stop and we end up in the same frame of reference, we can't both have aged more than the other. One will have aged more than the other, or we'll be the same age. It can't be that he can be older than me and I can be older than him. This cannot be the case. So there's some kind of problem with this now, and this is why it's a paradox. It's not possible for us both to be older than the other. You can't have A bigger than B and B bigger than A. It doesn't work. So this is when they leave, and when the spaceman comes back, we find that the one that has travelled, so to speak, is the one which has aged less. So the one that is still has aged more than the one that has travelled. The one that's travelled, his clock went slower than the person that stayed on the Earth. So the symmetry is broken. The twin who has not travelled has aged. So, and the reason the symmetry is broken is because in order for him to go somewhere and then come back again, he has to slow down. This slowing down means an acceleration. And if we have an acceleration, it's not an inertial frame of reference. So this idea of slowing clocks only works for inertial frames of reference. In other words, ones that are not accelerating. So this is why this symmetry is broken, and why how this paradox can be explained. And this is dealt with by general relativity, which is to do with accelerating frames of reference.